So full board க்கு draw பண்ணா கரெக்டா இருக்கும். Okay, I will draw.
Can you draw the margin line, sir?
Margin line. Is it okay now?
No, sir. No, sir. Left.
Here. Now.
இன்னும் கொஞ்சம்.
Here.
Left. இன்னும் கொஞ்சம்.
Here.
Yeah, okay. Right long. கொஞ்சம் ரைட் வந்தா போதும். Okay. அங்கதான். Okay, sir. Okay. Correct.
Yes. This side. Now.
Right.
Right. Here.
Side. Yeah, okay, sir.
Here.
Okay. Sir, left.
Yeah.
Left. Yeah, okay, sir.
Okay, I will draw thicker, whether it is visible or not. I will draw one magnet, whether it is visible or not, you can tell.
Yeah. Now it is okay, sir.
Okay, I will draw thicker. Okay, so now it is visible. So is it okay? Okay, I think it is okay. So in this induction type energometer, we have two electromagnets. So one magnet we are calling as a pressure coil magnet, another one is current coil magnet. So these two flux will interact each other. So and this will make the rotating disc to rotate. So this is the working principle. So next we are going to see the construction. So this is called M-shaped electromagnet. So we are giving the voltage across the central limb. So it will carry a current of number of turns, large number of turns. It has more inductance when compared to resistance. So it will lag the current will lag the voltage. If you have more inductance, current will lag the voltage. You know that. So there is a shading coil. So this will make you to perfectly the current will lag the voltage by 90 degree. So that is the purpose of this shading coil. Okay. There is a rotating disc. It will continuously rotate when you switch on the load. When there is any load, this rotating disc will rotate. The purpose of this braking magnet is when you cut off the supply. When you cut off the supply, there is no power to rotate the disc. So due to the already it is rotating. So due to the inertia, it will continuously rotate. So in order to avoid this braking magnet will apply some magnetic power to make it stop. So when the supply load is on, that power, braking magnet power is not able to stop the rotating disc. When there is no load, so there is no power to drive the rotating disc. So this braking magnet power is enough to stop the rotating disc. So another important feature in induction type energy meter. So it is displayed. We want to see the reading. So if you see the energy meter, the upper side you have some 4 columns. So it will indicate the value of the unit. So unit means kilowatt hour. 1 kilowatt hour is equal to 1 unit. So it has 4 values, 4 boxes. Normally it has 4 boxes. You can measure up to 9999 units. So after that it will become 0, and once again it will start from 0 and it will go count up to 999. It has 4 values. So you can measure up to 9999. So this induction type energy meter is widely used in India. So nowadays it is changed into LED type energy meter. So these are mostly replacing daily. So these are very rare. So it goes on absolute today. These are the construction of the induction type energy meter. Next one, how it works. So when you give a voltage, it will create a flux here. So it will create a flux here. So this flux will interact with the aluminum disc. So this pressure coil flux interact with the aluminum disc. Here a eddy current flows. Here a eddy current flows. That eddy current will create another flux. This eddy current creates another flux. For this flux, here already there is some flux. Here one flux, here another flux, because there are 2 coils. This flux interacts with this aluminum disc. That aluminum disc will produce a current, we are calling as eddy current. That eddy current will produce another flux. Okay? That flux will interact with this current coil flux. Due to the interaction, this disc rotates. Okay? So first pressure coil flux will interact with the aluminum disc. So due to this eddy current will flow. This will create another flux. That flux will interact with the current coil flux. Due to this interaction, the rotating disc will rotate. Okay. So when the power is, when you switch off all the loads, there is no current, but there is voltage. There is no current. So since voltage, it will create a flux. It will interact with the aluminum disc. Eddy current will create. There is a flux in the aluminum disc, but there is no current in the current coil magnet. Due to the absence of current in the current coil magnet, there is no flux here. So there is no interaction between the aluminum disc and the current coil flux. So this will not rotate. So it will stop. So it will not rotate. Whenever you switch on the load, the rotating disc will rotate, because this current coil flux will interact with the eddy current flux which is produced in the aluminum disc. If there is no load, there is no current, there is no flux in the current coil magnet. So this disc will not rotate. So this is a principle working in the induction type energy meter. Okay. So operating mechanism is this one. So you have to explain what is the construction. So you have to explain what is a shunt magnet, what is pressure coil, shading magnet, rotating disc, braking magnet, current coil. First you have to explain the construction. Next you have to explain the working principle. Next we move to the applications. I hope you understand this. So application is, it is used in daily homes. So used in homes, business, offices, industries.
Sachin? Sir, wait a minute, sir.
Hello?
Wait a minute, sir. Wait a minute. Sachin, Sundar Ganesh சாருக்கு வந்து ரெண்டு ஐடி இருக்கும், ரெண்டு நேம் இருக்கும், ஓகேவா? So in that one, if you click any one, there's a pin option is there. Just click the pin option.
Okay, sir.
If you click the Sundar Ganesh ID means three options will be there. One is pin, audio, and remove button. Okay.
Yes, sir.
You just
pin, sir.
touch the pin button.
Okay, sir.
What?
I pinned, sir.
Yeah, okay. Now you are seeing the board.
No, sir.
Now you can able to see the board.
No, sir. Only his face is there.
Sachin,
Sir?
there is two IDs there in Sundar Ganesh ID. Sundar Ganesh ரெண்டு ஐடி இருக்கும். Okay.
Okay, sir. Okay, sir.
ரெண்டாவது ஐடியை பின் பண்ணி பாருங்க.
Now I can see, sir.
Okay.
Thank you, sir.
Since I am using video in one ID and audio in another ID. Okay. So it is used in homes, it is used in business offices, it is used in industries. So in olden days, everywhere this induction type energy meter is used. Nowadays they are modifying to LCD. Why they are moving to LCD means, so you can take all the readings. So what is the maximum demand, what is the energy, current, everything you can take from the LCD meter. So in the induction type energy meter, you can measure only unit. So unit is kilowatt hour. So you can measure only energy. So but in LCD energy meter, you can measure the voltage, current, maximum demand, what is the time. So a lot of data you can take from the LCD energy meter. So that's why they are moving to the LCD energy meter. So in future, what will they do? They will take the reading from the EB office itself. They will not come to your home and tell what is the unit. They will just send the bill. So they will measure the reading from the EB office itself. So that's why it goes into smart energy meter. So we are calling it smart energy meter. LCD energy meter we are calling it smart energy meter. So here you have to take the reading only manually. You should come and you see the reading. What is the reading? So you cannot take from an instrument, or you cannot take from an internet cable. So only they are moving to the newer technology. So in our syllabus you have induction type energy meter. So we are studying this. So first unit we have DC circuit, AC circuits and measuring instruments. So this induction energy meter is the last topic. So we see some problems, extra problems. So I have given an assignment. I have posted an assignment in the Google Classroom. These two lateral entries, so I will, you contact me after the class. So I will invite you. Danny?
Sir, board is not clear.
Hello? Hello?
Sir, board is not clear, sir.
Now also board is not clear.
Sir, I hear my voice, sir.
Hello?
Yes. Sir, now it is okay. Now it's okay.
Okay.
Now it is okay, sir.
Okay.
Now it's okay.
So I have given an assignment 1. So it consists of some problems. So you have to solve this and you have to submit before CA. So 11, I have given the last date as September 11. So you see the study material, you see the question. Hello? Hello?
Sir, can you tell what you have written in the board, sir?
Board. This diagram or here?
Words.
Words. It is used in.
Both, sir.
used in homes, business offices, industries. This one or a fading coil or rotating disc. Hello?
Sir, tell 1 second, sir. The words we have written in the board.
Okay. So these are the applications used in for induction type energy meters. So used in homes. Homes means houses. Next one, business offices. So there are a lot of small business. They have also need electricity. So there is a energy meter they have installed in their business offices. Next one is industries. So industry, you have a lot of electricity is needed. So they have also implemented this energy meter for measuring the energy. So when I writing this, I have to write in bigger size. Okay. Now it is visible.
Yeah, now it is okay, sir. Now it's okay.
So I have to write somewhat bigger, then only it is visible. So this blackboard should be cleaned by water, then only it will be more visible. So due to the penetration of chalk piece, it becomes blur. Okay, so induction type energy meter is the last topic. So you should explain the construction, working principle, then what are the applications. Okay. So what is the advantage? So it is used for AC, used for measuring the, here when I write it is small, AC energy. So you can measure only the alternating current energy only. So it is lightweight. So lightweight it is portable. You can move from one place to another. You can easily portable, low cost. So these are the advantages in induction type energy meter. So next before going to the next unit, we start the next unit in the next class. So I will solve some more problems for better understanding of the subject. In the last class, we have seen about Ohm's law, Kirchhoff's law. That thing we have concentrated more. So today we see about nodal analysis and mesh analysis. So first problem. So there is a circuit. You have resistors in series. So a lot of resistors are there. Okay. The voltage given is 50 volt. For R1, R2, R3 up to Rn. Okay. So it is a series circuit. The voltage applied is 50 volts. For a lot of resistors, N, what is the N? N equal to 100. So you have 100 resistors in series. 100 resistors in series. 100 resistors in series. The question is, find the voltage drop across the 100th resistor. So I want to find the voltage across the 100th resistor. So voltage drop across 100th resistor. This is the question. How we can solve? Anyone? It is a 2 mark question only. So I want to find the voltage across 100 resistors. So total voltage drop is 50 volts. So it is a 50 volt is dropped across 100 resistors. Before putting formula itself, we can easily find out. So one thing is all the resistors are equal. All resistors value are equal. All resistors value are equal. Now anyone tell the answer? Without putting the equation or formula, you can easily find out. Anyone tell what is the voltage drop across the 100th resistor? The clue is all resistors value are equal. So all the resistors values are equal. Total voltage drop 50 volt. There are 100 resistors. Anyone tell what is the value of the voltage drop across 100 resistors? If you tell the answer, you clearly understand Ohm's law. Anyone know the answer? I will give you a minute. So I have told that all resistors are equal. Since all resistors are equal, all the voltage drop are equal only. So there are totally 100 resistors. Now tell what is the voltage drop across this resistor. Since all resistors are equal, V1 is equal to V2, which is equal to V3, which is equal to Vn. Okay? Now you can tell. So all the voltage drop are equal. So when you add all the voltage drop, you get the total voltage drop. So totally 100 resistors. What is the voltage drop across 100 resistor? No. Okay. So voltage, since V1 is equal to V2, V2 is equal to V3, which is equal to Vn. So this voltage drop is equal to this voltage, this voltage, this voltage. So voltage drop equal to total voltage drop is 50 volt. So I have 100 resistors. Voltage drop across one resistor. Voltage drop across one resistor is equal to 50 by 100, which is equal to 0.5 volt. This is the answer. If the values are different, you cannot apply this concept. All the resistors are equal. So I have not given the resistor value. You cannot put the formula here. So I have told that there are 100 resistors are there. All the resistors values are equal. So since all the resistors are equal, voltage drop across one resistor is equal to voltage drop across next resistor. All the voltage drops will be equal. Okay. So 50 volt is the total voltage drop. So I have 100 resistors. So every voltage drop is equal. So I am dividing the 50 volt by total number of resistors. So voltage drop across one resistor is 0.5. So if I multiply by 100, I get 50 volt. So this type of tricky questions will be there. So you should understand what they have given. Here I have not applied any formula here. So I have only understand that in a series circuit, if all the resistors values are equal, the voltage drop across all resistors are equal. That is the concept I have understand and I have implemented here. We have written this, we move to the next problem. We have finished, put in chat box, I have finished. I hope you understand this. Total voltage drop I know. So all are in series. Since all resistors value are equal, voltage drop across each resistor is same. So I am dividing the total voltage by total number of resistors. You get a voltage drop across one resistor. That is same in all resistors. So that voltage drop will be equal across 100 resistors also. So voltage drop across 100 resistor is equal to 0.5 volt. So shall we move to the next problem? Shall we move to the next problem?
Yes, sir.
Yeah.
Students completed.
Yeah. So next we see Kirchhoff's current law and voltage law. How we have to implement. We have already some problems. We will still more go into depth in KVL and KCL. So there is a 20 volt source, plus and minus. There are two resistors. They have given the polarity also, plus minus, minus plus. Here V1 is equal to 2 ohm, V2 which is equal to 3 ohm. Okay. So what is the question is, you have to find the V1 and V2. Question is, find V1 and V2. Seems to be simple. Okay. There is only one loop. Here there is no second loop and third loop. There is only one loop. So you have to write only one KCL equation. So I assume that it is clockwise direction. Okay. So here the current flowing is, we take it as I. Because there is no only one current, it is a series circuit. So all the elements, same current will flow. So first I am taking V1. V1 equal to, here plus, here minus. So it is positive, 2I. So V2, here minus, here plus. So first minus means, you have to write minus 3I. So first I have written the voltage in terms of current and resistance. So 2 ohm into I. So 2I. Here 3 ohm into I. But the sign is negative and positive. So it is minus 3I. So now you have to write the KVL equation. KVL equation. Plus 2 minus means it is V1. So in the last problem we are not saying any sign. So if it is a resistor, we will put positive. So here they have mentioned the sign. So in a resistor, if it goes from plus to minus, we take it as V1. So minus to plus, we take it as minus V2, which is equal to, here voltage rise. So here it is 20. Okay. V1 minus V2, which is equal to 20. V1 minus V2, which is equal to 20. So we have write the KCL equation. So voltage drop plus 2 minus in a resistor. So it is V1 minus 2 plus in a resistor means it is minus V2. So here in the voltage, these are voltage drops. Here it is voltage rise. So here you have to write minus 2 plus means it is positive. So it increased from 0 to 20. So you have to write positive 20 here. So we have already found that V1 equal to 2I, V2 equal to minus 3I, which is equal to 20. So 2I plus 3I, which is equal to 20, pi I equal to 20, I equal to 4 amps. So now I have find the current. Now I find the total current. So the same current will flow through the V1, V2. So since I have find the current, so I have easily found the V1 and V2. 2 into 4, 8 volts. 3, minus 3 into 4, it is minus 12 volts. So this is the answer for my solution. So if they are given positive and negative sign in the resistors, so first you have to find the voltages V1, V2. Then you write the KVL equation. So while writing the KVL equation, so when you go from positive to negative, so you have to take as positive. So if you go from negative to positive, you have to take as minus. So here there is another minus, it will get cancelled. So if there is no sign, you can take everything as positive. If there is no sign, if they are not mentioning any sign, means you take everything as positive. So V1 plus V2. So in the last problem we have done directly. There is no sign given. So we are taking everything as positive in the voltage graph. But when they are given the sign, then you have to move accordingly. If it is moved from plus to minus, you have to write positive. If we are moving from minus to plus, you have to write minus V2. Okay. So in here, voltage rise, same thing. Minus to plus means 20. Plus to minus means minus 20. Okay. This is one of the very important problem. So you have to write the KCL equation. We have already find the voltage in terms of current and resistance. Then we are applying that. So we are finding the current. So after finding the current, we are applying here and we are finding the voltages. The question is, you are asked to find V1 and V2. So if we completed, you inform me. We move to the next problem. So if you complete the problem, we go to the next problem. It is also based on sign notation. So here only one loop, single loop we can easily find out because there is only a single current. So we can easily find out with a single equation. If there are more branches, if another branch is there, means you have to go for the another KCL equation. Depending upon the circuit, you have to apply the concept. Write down the problem. So only one thing is the sign notation is very important. If there is no sign notation, you take as it is. So V1 plus V2. So in the earlier problems we have done V1 plus V2. So when there is sign notation, plus 2 minus means you have to give positive. Minus 2 plus means you have to give negative. So in voltage rise, minus 2 positive means positive, plus 2 negative means negative.
So students
Here
complete.
a voltage drop. Okay. Here voltage drop, here voltage rise.
Sundar sir.
Okay. We move to the next problem. So in this problem you have one more branch. So it will not, you cannot find the equilibrium value easily. So there is a 30 volt supply, plus and minus. You have three resistors, one resistor, second resistor, third resistor. Third resistor take line. Here also sign notation is given, plus minus 8 ohm, plus minus 3 ohm, plus minus 6 ohm. Now you cannot put the current I, because here the current will divide. So you cannot take I as it is. So what is the solution you have to find means, here it is V1, V2 and V3. So you have to find similarly V1, V2 and V3. Okay. So first we have to write the current. So instead of writing I, there are three currents. Here one current will flow. So here when it reaches here, it will divide into two. Because here only the source is there. So this current will come here. So I am taking as I1. Okay. So that I1 current will divide into two. Here I have one current, here one current. So I1 will divide into two parts. So I am taking this as I2. So this is I3. Okay. So first, similar to the old problem, we are writing V1, V2 and V3. So we are writing in terms of I1, I2, I3. So V1 is equal to 8I1, 8I1. V2 is equal to 3I2, 3I2. So V3 is equal to 6I3. Okay. So we have taken I1, I2, I3 in terms of V1, V2, V3. So after that we have to write the KCL equation. Okay. You can write two KCL equations. So one more technique is there, I will explain. So before go to the KCL equation, we can apply the KCL. This is KVL, here KCL. We can apply KCL as well as KVL. So in the particular problem, when you are asked to find KVL, so you have to apply KVL. So otherwise we can apply both KVL and KCL. So our ultimate aim is to find the solution. So whatever law you are applying is not a problem. So you have to find the solution, correct solution. So if you are asked to find only by KVL, you have to apply KVL. So when you are asked to find only by KCL, you have to apply KCL. They don't mention find a solution to this problem means to apply KVL, KCL, whatever may be. So here the current divides. Here there is a node available. So from this node, you can write an equation I1 which is equal to I2 plus I3, or I1 minus I2 minus I3 which is equal to 0. This is one of the equations. Because the current I1 is split into two, I1 is equal to I2 plus I3. So I am moving I2, I3 other side. So you get I1 minus I2 minus I3 which is equal to 0. Now I am applying the KVL. So when I am applying KVL, so plus 2 minus means V1, here also plus 2 minus plus V2 which is equal to, so here minus 2 plus, so it is 30. So it is 30. So we already know that V1 and V2. So V1 is 8I1 V2 is 3I2, which is equal to 30. Okay. From this, so I am taking 3I2 equal to 30 minus 8I1. So I2 equal to 30 minus 8I1 by 3. This is one more equation. So we obtain from this KVL. Now here another loop is there. Okay. So both are voltage drop only. So here plus minus means it is V3. So here minus plus. So it is minus V2. V3 minus V2, which is equal to 0. Here there is no voltage sources. The second loop, there is no voltage sources. So only voltage drop 6 ohm and 3 ohm. Here plus 2 minus means you have to write V3. Here minus 2 plus. So you have to write minus V2. So you know V3 and V2. V3 is 6I3. V2 is 3I2, which is equal to 0. So I am moving 6I3 equal to 3I2. So 3I2 is equal to 6I3. So I2 equal to 6 by 3I3. So I2 equal to 2I3. I2 equal to 2I3. So this is another equation. Okay. So first equation we are applying KCL. So our I1 is divided into 2. So I1 is equal to I2 plus I3. So I1 minus I2 minus I3 equal to 0. This is by using KCL. Since there are two meshes, two closed loops. So this is closed loop 1, this is closed loop 2. So we are writing two KVL equations. So plus 2 minus V1, plus 2 minus V2. So here voltage drop, rise minus 2 plus 30. So we are substituting these values. So we are taking in terms of I2. Okay. So I2 equal to 30 minus 8I1 by I3. So here I2 is equal to I3. You can also write I3 equal to I2 by 2. Okay. So this is one of the equations. So in the second loop, you are applying a mesh KVL, plus 2 minus V3, minus 2 plus, it is V2. So we are always assuming clockwise direction. So we are substituting the value, we get 6I3 equal to 3I2, 3I2 is 6I3, I2 equal to 2I3, or I3 equal to I2 by 2. Okay. So after finding this, you have to apply it in the KCL equation. So here, so everything we move in terms of I2. So I2 is this value. If I want to find I1, here in terms of I2, if I want to find I1, 8I1 equal to 30 minus 3I2, I1 equal to 30 minus 3I2 by 8. So instead of finding I2, I will take it as I1. Ready? So 8I1 is equal to 30 minus 3I2. So I1 equal to 30 minus 3I2 divided by 8. Here also, I take in terms of I3 in terms of I2. Okay. 6I3 equal to 3I2. I3 equal to 3 by 6 I2. So I3 equal to I2 by 2. Why I am making all the variables in terms of I2 means, if all the variables is in one variable, so I1 is equal to 30 minus 3I2 by 8. I can substitute here. So I3 equal to I2 by 2. I can substitute here. So after substituting, I have only I2. So I can easily find the value of I2. So after finding I2, I can easily find I1, I3. Then I can find V1, V2, V3. So every KVL equation, so I have both I1 and I2. So I make I1 in terms of I2. Similarly, I make I3 in terms of I2. Okay. So this equation becomes a single variable in terms of I2. So after finding I2, I can easily find other variables. That's why I'm making I1 in terms of I2 and similarly I3 in terms of I2. So why in terms of I2 means here also I2 available, here also I2 available. So here I1 is only present, here I3 is only present. Since I2 is common in both the variables, we are making another variable in terms of I2. Okay. So I1 equal to 30 minus 3 I2 by 8. So I3 equal to 3 by 6 I2, I3 equal to I2 by 2. Copy this. So after copying this, we move to the next step. Javed Mohammed. So here KCL equation, here KVL, here KVL. So I have applied 2 times KVL and I have applied 1 time KCL. So why I am making I1 in terms of I2 means here also I2 variable available, here also I2 variable available. So I am making I1 in terms of I2. Yeah. Yes, sir.
Sundar sir.
Yes, sir.
Sundar sir, are you hear my voice?
Yes. Do you hear my voice? Hello? Sir? Hello? Sir, have you heard my voice? Hello?
Sir, Sundar, admit sir, Javed Mohammed.
Admitted. Now only admitted. Students, whether I hear my voice, whether it is hearing?
Yes, sir, we can hear, sir.
Hello?
Sir, admit
Audible, sir.
Javed.
Hello?
Yes, sir.
Hello? Gautam sir? Hello? Hello? Gautam sir? Hello? Is it hearing? Hello? Hello? Is it audible?
Yes, sir, audible, sir.
Is it audible?
Yes, sir,
Hello?
audible, sir.
Hello?
Sir, audible, sir.
Sir, audible
Audible only. Okay. Thank you. this is only because we will be asking for 5%. So it is also important to see final. So every final notion we have what are the analysis. So this problem is always is a lesson analysis, but we are taking equation also. So we get this equation. So if they are not given any sign and resistance, we can take every voltage of the positive. So if there is a sign only, you have to consider that sign. So if there is sign means you cannot take it through current or sign. So if there is no sign only, we take it as current. If there is sign, take it doesn't consider this loop current. Take this branch currents. If there is no sign means don't worry about this positive and negative sign. You take the loop current I1, I2 and so on. So if there is a sign convention in the resistors, don't take this loop current. So it will continue. You have to see the problem. If there is sign terminologies, you should use the branch current. If there is no sign, only resistors means take the loop current. And then take all the voltage drops. You have to take all the voltage drops. If there is no sign. So after completing this step, we go to the next step. So put completed in the chat box. The result of this step. Then we go to the next step. So we have to apply this I1, I3 in the KCL in terms of I1. So you get a value of I2, then it is equal to other values. So our equation is I1 minus I2 minus I3 equal to 0. So the diagram. So I1 is 30 minus 3I2 by 8. So I2 is I2 only. I3 is I2 by 2 is equal to. So we have to take the common denominator. So you have to multiply by 2. So when you multiply, this gets cancelled. 30 minus 382. Here when you multiply here, it becomes 882. So here 8, here 2, so it becomes 482 is equal to. So 30 minus 1582 is equal to 0. So I add 2, so it is become minus. So we move here 1582 equal to 30. I2 equal to 1. So I can easily find that. So after I2, you have to find I1 and I3. So from this equation, I am applying I1 here, I3 here. So I1 is 30 minus 3 I2 by 8. I3 is I2 by 2. So I am multiplying by 8. So denominator gets cancelled. So it is only by 8. When you multiply by 0, it becomes 0. So adding this values, it becomes 30 minus 15I2. So it becomes 15I2 equal to 30, I2 equal to 2. Then I can easily find I1. 30 minus 3 into 2 by 8. 30 minus 6, 24. 24 by 8, 3 amps. So I3 is I2 by 2. 2 by 1, 2. 1 amp. Then we can easily find V1, V2, V2. V1 is 8A1, 8 into 3, 24 volts. I2 is 2, 3 into 2, 6 volts. 6 into 1, 6 volts. So from the problem, we are having 2 KVL equations, 1 KCL equation. So we are making all variables in terms of yes. So since I2 is common, we are making other variables in terms of I2. Then we are applying in the KCL equation, we get I2. From I2 we can find I1, I3, then we can apply V1, V2. So you get all that. So it is a simple one only, but you should know what is KVL, how to apply that. If there is sign convention, always use branch current. If it is here, there is no sign, you use loop current. Loop current means for first loop, this loop current I1. For second loop, it is loop current I2. So if there is positive and negative sign given, you go for the branch current. Then only you get the answer. If there is no sign convention, you go for loop current means that I2 is common for particular loop. I2 is common for the test loop. So if it is I1 minus I2 or I1 plus I2, depending upon the flow. Note it down. For this is KCL, we see one more problem in KCL. There is no way we can ask. Now it's here there are two variables. Why I am making I1 in terms of I2. So in the next equation also you get only I2. I am stop this equation here. So I am writing the KVL equation. So I am seeing this I2 is available here also. So after finding I2, we need to use this equation to find I1, I3, and V1, V2. So this is about KVL. So there is sign convention, we use the branch convention. If there is no sign convention, we use the loop convention. Okay. So in this model, DC circuits, AC circuits, everything you know the problem only. From the next model, it should be mostly theory. So I will put PPTs, I will put videos. For today's class after exam, I will put PPTs. So it will be clearly visible compared to the blackboard. So why this blackboard is black? Due to lighting on the dusting the blackboard, I don't know. So there are some problems in DC machines, a few problems. So whatever problems you take in the blackboard, the remaining things I put. So this problem is about KVA. In next problem, whether you have finished, I have written this. Hello, Gautam sir.
Yes, sir. Yes, sir.
Can we move to the next problem?
Okay, wait a minute, sir. Students, once you completed, post a message as completed. Once you completed the problem, post a message as completed. We will go for the next one.
Could you make that move to the next problem? So one more problem in KVA AC. So node voltages. So we had
Students completed, sir.
So while applying AC, you have to be careful going back in the transfer. This. Well, I will be down. I am given posting bank. You study the problems. If you have any doubt, you can ask me. Okay, last problem. By using AC. So they are given this. You have to find node voltages. Question is you have to find node voltage. So before solving the problem, you have to draw the direction. So I am assuming that this I1 is 5 amps. So here the current direction is like this. So it will go here. So it will come from here. Okay. It will come from here. It will go here and it will come. And then it will current as I5. Okay. So this will come. This is divided. Okay. So from this point, here it is 0 point. So it is the reference node. So it is 0 voltage. So current will go here only. Here and here. So in this point itself it will go here. This point itself it will go here. Okay. So here, so this current will go here. Some of the current will go here. Some current will go. So in this point, here node, here node. So I'm taking node 1, node 2. So in this point, you have one current entering, two currents are leaving. Here, there are two currents entering and two currents are leaving. So totally there are 4 nodes. So this point 0 volt it is reference node. So in nodal analysis, I have to take a reference node and you have to find the nodes there more than 3 elements, more than 2 elements are connected. So in this point, there is a current source, resistance, and a resistance. 3 elements. So here, 1, 2, 3, and 4. 4 elements. So totally there are 2 nodes. So after writing the current connection, you have to write the variables. So I'm taking this as I2, this as I3, this as I4, this is I5. The current connection will be like this. So in between this is B. Okay. Now you have to apply the KCL. So at node 1 as well as node 2. Okay. So node 1, what are the input currents? I1 is the input. So at node 1, I1 is the input current. So I am taking as I1. Small I1. Normally I write small I1, small I2. Okay. So I1 is the input current. Outgoing current is I2 plus I3. Both are outgoing current. So here the current is 5 amps is coming. This voltage is greater than this voltage because it is 0 volts. So current will flow here. So remaining current will flow in the 4 volts. So here current 10 amps is coming. So here current direction is like this. So it will come from here. So it is so if this voltage is greater than 0 volt, so current will flow from top to bottom. So I4 is also flow from top to bottom. These are the current direction. First you have to draw this. So after that you have to give a name. You can give any variable. So I have taken like this for my understanding. You can give this I1, I2, I3, I4, I5. You can give any name. So what is I1? What is I2? It is V1 minus V2. V1 minus V2 by 4. So what is I3? It is V1 minus 0 by V1 minus 0. Okay. So I have written the equation in the node 1. Okay. Now I have to eliminate the denominator. So in order to eliminate the denominator, I have to multiply by 4 throughout. So while multiplying by 4 throughout, I will eliminate the denominator. So multiplying by 4 throughout the equation. So 5 becomes 20. So 4 get cancelled, V1 minus V2. So 2 is multiplied by 4. So you get the 2 value. 2 is 1. 0 is always 0. Whatever multiplied by 0, it is 0. Now 3V1 minus V2 is equal to 40. This is one of the equations. Now you have to write the second equation at node 2. Okay. So at node 2, what are the incoming currents? I2 and I5 are incoming currents. I2 plus I5 it is equal to outgoing currents I1 and I4. So I1 plus I2. Now I am writing in terms of V by R. So I2 is V1 minus V2 by 4. So I5 is 10 amps. I1 is 5 amps. I4 is V2 minus 0 by 6. V2 minus 0 by 6. So I'm moving V2 here, V1 V2 by 4. Plus becomes minus V2 by 6. Here 5 minus 10. Okay. So I'm moving 10 there and V2 minus 6 here. Okay. So this becomes minus 5. V1 by minus V2 by 4. Minus V2 by. So in order to eliminate the denominator, so I have to multiply by 1. So when I multiply by 2, all the denominator factor will be eliminated. So I am multiplying by. So multiplying by 1. So it get cancelled and becomes 3V1 minus 3V2. So 6 and 12, you get 2 minus 2V2. So 12 into minus 5 is equal to minus. Okay. 3V1 minus 3V2 minus 2V2 minus. So I have further simplification. 3V1 minus 5V2 equal to minus. So I am multiplying by minus 4 means minus 3V1 plus 5V2 is equal to. This is another equation. So in order to make this value positive, I am multiplying by minus throughout the equation. So this becomes minus, this becomes positive, this becomes positive. So now I am applying grammar. One equation is D minus 1 D1 B2. D1 B2 is equal to here 20, here 60. Here minus 3 plus 5. So this is the equation for this particular equation 1. This is equation 1. Now I have to find the V1 V2. So V1 is del 1 by del, V2 is del 2 by del. First find del. So del equal to 3 minus 1 minus 3 5. So 15 3 into 5 minus 1 into minus 3. 15 minus 3 which is equal to 12. Okay. So this is del. Next you have to find del 1. Similarly del 2. Del 1 means you have to replace the first column by the last column. 20, 50 minus 1 5. So this is equal to 100 minus 50. So 150. Then 2 equal to 3 minus 3 20 60. This is equal to 180 minus 50. This is equal to 240. Okay. Now we have to find the V1 and V2 by grammar rule. V1 equal to del 1 by del. This is equal to 160 by 12. V2 equal to del 2 by del 240 by 12. 20 volts. Here it is 140 by 12, 13.33. So this is the. So first from the circuit you have to draw the branch current. How the current flowing. Then you have to assign in I1, I2, I3 and I3. So after that you write writing the KCL at the nodes. Then after writing the KCL, you have to write in terms of voltage and resistance. So after writing the voltage and resistance, you cancel the denominator by multiplying by suitable value. You get two equations, then you apply the Cramer's method, Cramer's rule, and finding the V1 and so in this problem, if you have any doubt, you can ask me. So this KVL and KCL is very important because this analysis and model analysis is important in final exam. So in the final exam, you are reading one question, maybe mesh analysis or nodal analysis. So should be very thorough by applying that. So while writing the KCL equation, you should very confident that which current is entering, which current is leaving. While writing the KVL, you should know whether it is plus minus or minus plus. If there is no on sign notation, go for the two currents. So it is easy. There is sign convention, you have to first draw the branch currents. So what is the value of current going in each branch? First you note it. Then only you apply the KVL. Then only you get the correct. This is a problem in KCL. You have already seen KVL. So first you need DC circuits, Ohm's law, KVL, KCL, mesh analysis, nodal analysis. In AC circuits, they will give you a RC circuit or RC circuit or RC circuit to find the voltage, impedance, power factor, etc. So if we go for the three phase, whether it is star or delta, you have to find the power, active power, reactive power, and current power. So these are the main problems coming in the model 1. So theory part means it is only measuring instruments, whether they will ask resonant magnet moving coil meters, ammeters, or MI meters, moving ion meters, or dynamometer, wattmeter, or induction dynamometer. There are 4 questions. They will ask me to. So the theory part, these are problems. With the DC circuit as well as AC circuits, there won't be any theory questions. The only problem for you. So you should know how to apply that. So KCL and KVL it should be very thorough. And you should also know how to find the impedance, power factor, current power, real power. So what is the voltage in relation to star connection and delta connection? Then you can easily score marks in this first unit. Is there any doubt in this problem? Is there any problem? Any doubt? To near Thomas, David, and Sachin. So we are seeing some particular so we have finished the model 1. I have given an assignment. Go through the assignment. If you have any doubt, you can solve me. So you have to finish the assignment before next week. So before the CPA is on 16. B50 is on 16. Start on 17. Start on 12. Saturday it is starting. Our exam is on 16. It is an online mode only. There is a portal available. So you have to write in that particular portal. If you have any doubt in this particular problem or previous problem, you can ask. So otherwise you can close the class. Advanced level. But the time is 10. For next unit, we go to the DC machine. So in the DC machine, we study about what is the DC machine. So in the DC machine, there are two types. One is generator and one is another one is motor. So generator is used for generating the power. So motor is used for producing the rotating power, rotating motion. So in many applications, we use motor for pumping operations, for transporting the material, etc. We use motors. Motors are widely used in industries and other applications. This is the construction or working principle applications. What are the different types of motors? What are the characteristics of this particular motors and generators? So next we go to the transformer. So how the transformer works? What is the construction? What is the working principle? What are the advanced applications of the transformer? So next model, next topic is single phase induction motor. So single phase induction motor in also we are using fans, mixes. So everything is single phase induction motor only. So we do what is the principle behind the single phase induction motor. So this is first of unit 2. The unit 3 is about transistor, what is a diode, how it works during the positive of cycle and negative of cycle. So what is a transistor? What are the types of transistor? Next one, what is a rectifier? So a rectifier will convert AC to DC. Types of rectifier. So these are the second or this model we are seeing studying about physics as well as the electronic engineering. So we start from the next Wednesday. So today we have seen some problems. We go through the assignment this weekend and before solving that, you study the question bank. So it is similar to that same type of model. You first study that and you go for solving the assignment. If you have any doubt, if you have any doubt, you can close the class. Now you can read it. Okay, you can now leave the class.